Hello and welcome back to e-CBSE online classes. We're continuing the module probability for mathematics class 10th. The specific topic of today's video is theoretical probability. This is part B1 of this video series in this module. Before we go any further, let's quickly recap what we have learned in the previous module. We have looked at the definition of empirical probability. As per the definition, the empirical probability P of E of an event E happening is given by the ratio of number of trials in which the event E happened to the total number of trials. Okay, this is an experimental way of finding out the probability. And the equation is P of E is equal to number of trials in which the event E has happened divided by the total number of trials. Okay, but experiments are expensive, especially when it is involved with a huge experimental setup, example rocket launch, spacecraft, etc. And sometimes it is not even feasible to perform experiments. For example, if you want to predict the probability of earthquake or hurricane, you cannot really mimic those or perform any experiments. So what to do and how to deal in such situations? With some assumptions, the probability can be calculated theoretically. That's where you will use theoretical probability. Okay, now let's look at the definition of theoretical probability. The theoretical probability P of E of an event E happening is given by the ratio of number of outcomes favorable to the event E to the total number of all possible outcomes. Okay, observe the keywords here: favorable to the event and all possible. Okay, when it says favorable and all possible, we're not performing the experiments. We are basically theoretically looking at what are all the possibilities and what are the favorable outcomes in that experiments to the event E. Okay, the equation goes like this: P of E is equal to number of outcomes for favorable to E divided by number of all possible outcomes. Okay, now let's go back to the experiments that we have done in the previous video. We have done this coin tossing. What we did is we took a coin and toss it 10 times and noted how many times we get head, correct? And we have repeated the experiment to observe how the ratio of total number of heads to the total number of tosses is varying, right? So if you notice the third column here, if I do the experiment only 10 times, the ratio was 0.6. If I repeat it, the experiment 20 times, the ratio was 0.5. And after I repeated the experiment for 30 times, the ratio has come down to 0.433. So it is varying, right? Now let's see how we can calculate the same probability theoretically. Okay. Now before that, let's keep the definition of theoretical probability here. P of E is equal to number of outcomes favorable to E divided by number of all possible outcomes. And what we also said is, with some assumptions, the probability can be calculated theoretically. Now, with coin tossing, what are all the possible outcomes? There are only two possible outcomes, right? Either it can be head or it can be tail. And what is the assumption here? My assumption is that the coin is fair and head and toss are equally likely. Notice the word equally likely. We are going to use this assumption in most of the problems that we are going to deal in future videos as well. So number of all possible outcomes here is 2. And when I want to know the probability of the outcome to be head, the favorable outcome is head, right? Just 1. So probability of the outcome being head is 1 by 2. Similarly, number of favorable outcomes for tail is just 1, correct? So P of tail is also equal to 1 by 2. Notice here, the sum of probabilities for head and tail is equal to 1 because those are the only two possible outcomes. Remember this point. And now let's look at experiment number 2 that we have looked at in the previous video. What we did is we took a die and rolled it 100 times and filled the following table. We have noticed how many number of times the outcome is 1, how many number of times the outcome is 2, and so on up to the outcome of 6. Okay, the total number of outcomes is 100, and we have calculated the probability of the outcome being 1 as 0.13, right? Because we got 13 times 1 in the previous experiment. But now if you repeat this experiment multiple number of times, the outcome of calculation of probability will be different, right? Now let's see what would happen if we calculate the same thing theoretically. Again, the equation is P of E is equal to number of outcomes favorable to event E divided by number of all possible outcomes. And as I said, with some assumptions, the probability can be calculated theoretically. Now, when you roll a die, what are all possible outcomes? The outcome will be either 1, 2, 3, 4, 5 or 6, right? And what is the assumption here? The die is also fair and all possibilities like 1, 2, 3, 4, 5 and 6 are equally likely. So there is no bias towards any specific value here. Okay, now the total number of all possible outcomes is 6 here. And if I want to know the probability of the outcome being 1, what is the number of favorable outcomes for 1? It is just 1, right? So the probability of the outcome being 1 is 1 by 6. Similarly, number of favorable outcomes for the outcome to be 2 is another 1. So P of 2 is also equal to 1 by 6. Similarly, P of 3 is also 1 by 6. P of 4 is 1 by 6. P of 5 is 1 by 6 and P of 6 is also 1 by 6. So again, you should notice that the sum of the probabilities of all these events like P of 1, P of 2 and so on up to P of 6 is also equal to 1. Okay, please remember these points. Now, before we close this video, let us quickly remember the points that we have learned. In many situations, the experiments are expensive, like rocket launch and spacecrafts, and in some situations it is not even feasible to perform experiments like earthquakes and hurricanes. So in such situations, with some assumptions, the probability can be calculated theoretically. With sufficiently large number of trials, value of empirical probability approaches to that of theoretical probability. For example, in the coin tossing experiment, if you perform the experiment infinitely large number of times, the probability of head empirical will be equal to the theoretical value, which is 1 by 2, that is 0.5. Okay. Now, sum of the probabilities, both empirical as well as theoretical, of all possible outcomes is 1, right? So in the coin toss case example, probability of head plus probability of tail is also equal to 1. And in the die case, when we roll it, the sum of the probability of 1, 2, 3, 4, 5 and 6 is also equal to 1. Okay, please remember these points. And stay tuned. In the next video, we are going to work out some exercise problems in the probability. That should be really fun. I hope you like this video. Please like, share, comment and subscribe to our channel e-CBSE online classes and follow us on Facebook. Thank you.